Alright, today is day 3 of the Advent of Cyber event, and today's room is going to be Splunk Basics. Did you SIEM? It's almost Christmas in Wareville, and the team of the Best Festival Company is busy preparing for the big celebration. Everything is running smoothly until the SOC dashboard flashes red. A random message suddenly appears. 1,000 Hopset coins for McSkitty. Or SOCmas ends tonight. So the learning objectives for this room is to ingest and interpret custom log data in Splunk, create and apply custom field extractions, use search processing language to filter and refine search results, conduct an investigation within Splunk to uncover key insights. Before moving forward, review the questions in the connection card below. Do I need an attack box? No. Do I need to start a VM? Yes. Is there split screen available? No, which is a bummer. Is there a direct link available? Yes. Am I giving credentials to connect? No. So target machine, we're going to go ahead and start this. All right, so now that we have our IP, we're going to go to this link here to start our VM. Bad gateway. Looks like it's kind of buggy. There's a lot of people on right now. It's exactly 11 a.m. So I wanted to be one of the first ones here. So we're just going to give this time to really load up. And while we're waiting on that, we'll just check out some more of the room. So exploring the logs. In the Splunk instance, the data has been pre-ingested for us to investigate the incident. On the Splunk interface, click search and reporting on the left panel as shown below. Okay, so we're fully loaded up, search and reporting. And this is just a search query here. We can search for a specific term, analyze your data with tables. On the next page, type index at main. In the search bar to show all ingested logs. Note that we'll need to select all time so we can see all of the history. So let's go ahead and do that. And instead of 24 hours, like I said, we're going to do all time, and then we're going to hit search and see what we find. Okay, so it looks like the most activity was on October 10th through the 14th, and then it kind of dumped off after and before. So we're going to see what's going on there. After running the query, we'll be presented with 2 separate data sets that have been pre-ingested into Splunk. We can verify this by clicking on the source type. So let's go back to source type, and we see web traffic and firewall logs. Web traffic is 91% of the events. So we're going to start a basic search across index using custom source type, using the following query. So let's go ahead and do that. Okay, and we see a bunch of requests here. We see the request, we see the response, we see the URL, we see the user agent. So let's break down our result for a better understanding. So search query. This query retrieves all events from the main index. Time range. The time range is currently set to all time. In security analysis, this range will be tightened after initial data loading. Timeline. The visual histogram shows the distribution of 17,000 events over time. The graph indicates the successful daily log volume followed by a distinctive traffic spike. A period of high activity, likely the attack window. Selected fields, these are all the fields currently chosen to be displayed in summary column of the event list. They represent basic metadata about the log file itself. So interesting fields. This pane lists all fields that Splunk has automatically extracted or manually added. Fields prefixed with the # are automatically generated by Splunk time command. The presence of user agent, path, and client IP confirms the successful parsing of web log structure. Event details and field extraction. This section shows the parse details of a single event with extracted fields like user agent, path, status, client IP, and more. So now visualization, right? So I guess they want us to do another query with index, web traffic, and a time chart in one query. So we're gonna go ahead and do that. We can append the reverse function at the end to display a result in a descending order, showing that the maximum number of events at the beginning. So let's go ahead and do that. And again, here from October 10th all the way to October 14th is the highest amount of events compared to the rest of the month. Anomaly detection. Now that we've examined the days with abnormal logs using the table and graph, let's use the same search query to examine various fields to hunt for suspicious values. We need to go back to the events tab to continue. As you can see, 17,000 events, and there's a lot going on here. So this is just further breaking down client IP, the path, filtering out benign values. We know that King Malware's bunnies use scripts and tools, not standard browsers. Let's filter out all standard traffic. Let's exclude common, legitimate user agents. So that's going to be Firefox, Google Chrome, and browsers of that sort. The following query will remove legitimate user agents from the results and only show the suspicious ones, which we will further investigate. So let's go ahead and get this search query just so we can filter out all the legitimate. So this Windows, this Macintosh, all of these are legitimate. This iPhone on iOS 17.5, all of these are legitimate. So we're going to filter all of those out. Narrowing down suspicious IPs. In real-world scenarios, we often encounter various IP addresses constantly attempting to attack our servers. To narrow down on the IP addresses that do not send requests from common desktop or mobile browsers, we can use the following query. Tracing the attack chain. We will now focus on the selected attacker IP to trace their steps chronologically, confirming the use of multiple tools and payloads. Don't forget to replace redacted with the IP we noted down previously. So let's go back up. So this is the actual client IP here. And for client IP, we're going to replace that with this IP address. So now that we've input that search query, we can now see this IP again here. So now we have a new query for tracing the attack chain. We're going to do this, but with the now discovered IP address here where it says redacted. We're just going to replace that. We're going to search again. So now here we can see the time, we can see the path, We can see user agent as well as the status code that they got. So did they have anything successful? I don't see any 200 requests. Let's see. So what we just did is called footprinting. We will start searching for the initial probing of exposed configuration files using the query below. We just did that. The result confirms the attacker used low-level tools, curl, and wget, and was met with 404, 403, and 401 status codes. So next is going to be enumeration, vulnerability testing, search for common path traversals, and open redirect vulnerabilities. So now we're going to check all of the ones with a redirect. We're going to need to go back and get that IP one more time. And we see here is access.csv all the way down multiple times. Redirect to evil.site. Someone was in the password directory. This was a redirect. The output shows the resources the attacker is trying to access. So let's update the search query to get the count of the resources requested by the attacker. This search query is filtering on the paths that contain ... or the term redirect in it, as shown below. This is done to look for footprints of path traversal attempts. 2, we need to update the search query to escape the characters. So one more query here. And this is here again, the evil.site and the password directory. So next we're going to check for SQL injection attacks. Find the automated attack tool and its payload by using the query below. Let's go ahead and get that. And here we can see all of the SQL injection attempts here and all of the payloads that they were trying to use. Some they actually did use because we can see some 200 requests, which means that they were successful. Above results confirms the use of known SQL injection and specific attacks using strings like sleep5. A 504 status code often confirms a successful time-based SQL injection attack. So 504 as well as 200 are success codes. Exfiltration attempts. Search for attempts to download large sensitive files such as backups and logs. We can use the query below. Logs. And you can see the user agent they're using here, or the tools they're using curl, they're using wget, they're using zgrab. The results indicate the attacker was exfiltrating large chunks of compressed log files using tools like curl and zgrab and more. We can confirm the details about these connections in the firewall logs. So next section, ransomware staging and RCE, which is remote code execution. Results for sensitive files like logs and /config indicate the attacker is gathering data for double extortion. In the logs, we identify some requests related to bunnylock and shell.php. Let's use the following query to see what those search queries are about. Let's get that IP. You should have it memorized by now, right? So here again, we see the paths, we see user agents and status codes. So here we see a bunch of shells, bunny locks. We see Python, Ruby, zgrab again, wget again, curl again. Above results clearly confirm a successful web shell, which is very bad. The attacker has gained full control over the web server and is also able to run commands. This type of attack is called remote code execution, or RCE. The execution of shell /bunnylock bin indicates a ransomware-like program executed on the server. So next section is correlate outbound C2 communication. We pivot search to the firewall allows using compromised server IP as the source and the attacker IP as the destination. So this is going to be the local IP or the victim IP, and then the other redacted IP that we're going to change is going to be the attacker IP. And they were allowed a lot of different times. C2 contact, port 8080. Here's the source IP, which is the local IP, destination IP, which is where that data is being sent over or that connection is being established to, which is the attacker. This query proves the server immediately established an outbound connection to the attacker's C2 IP on the suspicious destination port. The action allowed and reason C2 fields confirm that a malware communication channel was active. Volume of data exfiltrated. We can also use the sum function to calculate the sum of bytes transferred using the bytes transfer field as shown below. And as we can see here, over 126,000 bytes were stolen. The results show a huge, I'm guessing this is supposed to say huge. The results show a huge volume of data transferred from the compromised web server to C2 server. Conclusion, identity found. The attacker was identified via the highest volume of malicious web traffic originating from the external IP. Intrusion vector, the attack followed a clear progression of the web logs. Reconnaissance probes were initiated via curl and wget, looking for configuration files and testing path traversal vulnerabilities. Exploitation, which is how they actually got in. The use of SQL map user agents and specific payloads like Sleep 5 confirmed the successful exploitation phase. Payload delivery, the action on objective was established by the final successful execution of the command bunny lock, which is the exploit they ran via the web shell. C2 confirmation, the pivot to the firewall logs proved that post-exploitation activity, the internal compromised server established an outbound C2 connection to the attacker's IP. Okay, let's see. What is the attacker IP found attacking and compromising the web server? Again, I should have it memorized by now, right? Which day was the peak traffic in the logs? We should have been answering these all along, right? So we can just go back. So friendly reminder, when you're doing these boxes, it's good to look at the actual questions at the bottom instead of having to do what I am doing right now. Okay, here we go. So October 12th was the day with the most. So let's go back. We have to do the day. So it's going to be October is what, 10? And what year was that? 2025. So it's going to be 2025, 10, 12. And there we go. What is the count of the Javi user agent events found in the log? It wasn't one, so we may have to go back and modify the search query to pull out all of these. 993 events. How many path traversal attempts to access sensitive files on the server were observed? So I believe that is up here. $347. No, that's actually wrong. So we might just have to go back and so this redirect here was 633 times. So let's try that. Still incorrect. Okay, so let's just redo this search query here. 658 times. Alright. Examine the firewall logs. How many bytes were transferred? $126,000 bytes. And that's going to be our last flag.